The night sky, an ancient tapestry woven with billions of stars, each a distant sun, many orbited by planets. For centuries we have looked up not just with wonder but with a profound question: are we alone? The sheer scale of the cosmos, the staggering number of potential worlds, suggests an emphatic no. Yet when we listen, when we search, all we find is silence. This is the heart of the Fermi Paradox, a cosmic riddle that chills the very soul. It begins with a simple observation made by physicist Enrico Fermi in 1950. During a lunchtime conversation discussing flying saucers and the possibility of extraterrestrial life, he famously asked, "Where is everybody?" A seemingly innocent question, yet it unravels a universe of disturbing implications. Consider the numbers. Our own Milky Way galaxy contains an estimated 100 to 400 billion stars. Current estimates suggest that at least 1 in 5 of these stars hosts an Earth-sized planet in its habitable zone, the region where liquid water could exist. That's tens of billions of potentially life-sustaining worlds in our galaxy alone. And the Milky Way is just one of an estimated 2 trillion galaxies in the observable universe. The numbers quickly become astronomical, almost incomprehensible. If life is not an incredibly rare fluke, if it can arise under suitable conditions, then the universe should be teeming. Given enough time, and the universe has had nearly 14 billion years, some of these life forms should have evolved intelligence. And given even more time, some of those intelligent civilizations should have developed advanced technology, capable of interstellar travel, capable of broadcasting their presence across the void. Even at speeds far below the speed of light, a civilization could colonize an entire galaxy in a relatively short geological timescale, perhaps a few million years. That might seem like an eternity to us, but it is a blink of an eye in the cosmic timescale. So if life is common, if intelligence is inevitable, and if technology allows for galactic expansion, then where are they? Why do we not see their megastructures, their probes, their signals? Why is the universe so profoundly, unsettlingly quiet? This is the paradox. The logical expectation of widespread extraterrestrial life clashes violently with the absolute lack of observational evidence. It forces us to confront a series of unsettling possibilities, each more disquieting than the last. Perhaps the first and most optimistic explanation is that we are simply looking in the wrong way or in the wrong place. Our search efforts, though growing, are still incredibly limited, a mere whisper in a hurricane. We are listening to a vast ocean with a teacup, or perhaps their signals are too alien for us to recognize. We are searching for patterns we understand, for messages structured like our own. An advanced civilization might communicate in ways we cannot yet conceive or use technologies that appear to us as natural phenomena. Another possibility suggests that advanced civilizations might deliberately choose to remain silent. They might adhere to a prime directive, a non-interference policy, allowing nascent civilizations like ours to develop naturally uninfluenced. Or they might simply find us uninteresting, a primitive species not yet worthy of contact. This explanation, while less chilling, still implies a vast, unseen intelligence observing us, a cosmic zoo scenario where we are the exhibits. It strips us of our perceived uniqueness, making us just another specimen under a watchful, silent gaze. But what if the silence is not a choice but a consequence? This leads us to the more ominous explanations, often grouped under the Great Filter hypothesis. This theory proposes that there is some immense, insurmountable barrier that prevents life from reaching advanced interstellar stages. The Great Filter could be behind us, meaning the difficult steps are in our past. Perhaps the emergence of life itself is incredibly rare. Or the jump from single-celled to multicellular organisms, or the development of intelligence, is an astronomically improbable event. If so, then we are exceptionally lucky, a unique anomaly in a barren universe. This perspective offers a strange comfort, placing us at the pinnacle of cosmic evolution for now. It means the universe is not teeming with life because the conditions for its emergence are so incredibly specific, so impossibly difficult to meet. However, the Great Filter could also be ahead of us. This is the truly terrifying prospect. It suggests that most, if not all, advanced civilizations inevitably encounter a catastrophic hurdle that wipes them out before they can spread across the stars. This filter could be self-inflicted: nuclear war, ecological collapse, runaway artificial intelligence, or a technological singularity that destroys its creators. Many of the existential threats we face today could be universal filters, a common fate for any species that reaches a certain level of technological prowess without achieving sufficient wisdom. If this is the case, then our future is bleak, almost predetermined. Every advanced civilization before us has fallen into the same trap, and we are merely hurtling towards our own inevitable demise. The silence, then, is not indifference, but a graveyard. Another filter could be external: a gamma-ray burst, a rogue black hole, a supervolcano, or a recurring cosmic event that periodically sterilizes galaxies or entire sectors of space. These events would be indiscriminate, wiping out life regardless of its technological level. Consider also the dark forest hypothesis, a chilling concept suggesting that the universe is a dangerous place where any civilization broadcasting its presence is inviting its own destruction. In this scenario, silence is not merely a choice but a survival strategy. if resources are finite and competition is inevitable, then the safest course of action for any advanced civilization is to remain hidden, to listen, and to eliminate any potential competitors before they become a threat. The universe then becomes a vast, dark forest where every rustle of leaves might signify a hunter or prey. In this grim vision, the silence is not empty but pregnant with unseen threats. Every advanced civilization knows this, and so they hide, listening in terror for any sign of another. The first to reveal themselves perishes. The Fermi Paradox forces us to confront our place in the cosmos, not as a given but as a profound mystery. Are we an improbable miracle, a lonely beacon in a vast, empty expanse, or are we merely an early stage in a tragically common story destined to repeat the mistakes of countless civilizations before us? The chilling silence of space, therefore, is not just a lack of data. It is a profound question mark hanging over our very existence, a cosmic mirror reflecting our deepest fears and our most audacious hopes. It compels us to look inward, to consider the fragility of life, the precariousness of intelligence, and the immense responsibility that comes with being the only voice we can hear in an otherwise silent universe.